Hello, and I do hope you're all well. Everyone, whether you work in an office or a factory, is likely to have heard of the terms Lean or Six Sigma. But what do these actually mean, and which one's best? If your business is just starting along this business improvement journey and trying to decide between these two leading approaches, this can be quite a struggle. The practitioners and the consultancies that promote each of these methodologies always seem to be adamant that their methodology is best, and of course that this is the one that you need. Well, the first spoiler alert. In many ways, the argument between Lean and Six Sigma is trying to argue which one is best between the screwdriver and the hammer. It really depends on what you need to fix. So, welcome to today's video from the Greybeards Academy. Within less than 15 minutes, we hope to give you a really good understanding of what each of these terms, Lean and Six Sigma, mean, what they are, the basics of how they work, what they're good at, and whether one is indeed better than the other. My name is Carl, and I'm a business improvement greybeard. Lean and Six Sigma are two business improvement systems or methodologies. They are two from amongst many that have been launched and promoted over the last 40 years or so. Some others that you might possibly have heard of would include TQM, value management, business process re-engineering, agile, quality management, process management, and total productive maintenance, amongst many others. From all of these attempts at systemising and branding business improvement, these two, Lean and Six Sigma, are by far the most successful and popular. Both systems have at their core an ambition to achieve business performance improvement. Both, like all the other systems mentioned, use many of the same common tools and techniques for business improvement, such as performance measurement, standard operations, root cause analysis, and a wide variety of basic quality tools such as fishbone diagrams, check sheets, and Pareto charts. However, there are some fundamental differences in philosophy and emphasis between the two systems. They both want to achieve the same goal, but they go about it in slightly different ways. Lean centres on the concept of value, the essence of what a customer is willing to pay a company, team or individual to generate and deliver, and its antithesis, waste, which is any or all of the things and time spent within a business when value is not being created. Imagine, for example, your business rents an office. Any time when the staff or the equipment within that office are not creating value, that office is still incurring cost, but it's not contributing to business success. And this in Lean is treated as the greatest of evils. Similarly, but different within Six Sigma, the philosophy that is the root of all evil is process variation. Variation outside of tolerance or contractual requirements results in scrap, rework and lost time. But as a wider principle, variation also disrupts flow, undermines our ability to forecast and plan, and introduces the need for buffers, surplus resources and wastes. So, looking in turn at each of the two methodologies in a little more detail. Lean is really a mindset. This mindset is based upon the relentless pursuit of perfect customer value creation. By design, the Lean approach is made up of 5 sequential steps, although the steps can have a little overlap. The foundations of Lean are first the specification of value and then the definition of the value chain, the sequence of processing steps in which our area or business creates value. This is why the establishment of an appropriate suite of performance measures is so important, and why within the Greybeard Academy we have focused so much within our early videos on KPIs and things like the production of SIPOC diagrams. These foundational steps ensure that we establish strong oversight of our performance, giving us good feedback on how effective we are in delivering the needs of the customer and how cost effective and time efficient we are with the resources that we need in order to achieve that level of performance. We need to know where we are before we set off to achieve our goals or destination. Within these first couple of steps of Lean, we've not actually made any physical changes to the process or the efficiency of our activities. We've concentrated on establishing understanding of our performance as it is now and exactly where we need to get to. The next step of Lean is where we start to deploy business improvement tools and techniques. This next step is called making value flow, and this is actually a combination of two different things. The first is the continuous identification and elimination of wastes within the process in order to continually reduce the lead time needed to deliver value. The second is then to pursue the balance of the size of the work tasks at each of those process steps, and this helps reduce losses due to the ebbs and flows of production batches so that work can genuinely flow along the value chain. The aim here is to get to the stage where every step is eventually the same size so that all the jobs in the sequence take a single step forward from one process step to the next in unison. The fourth step of Lean is then to focus on how we organise the demand, scheduling and delivery of work tasks. This pull stage tries to work towards a goal of only making or doing those exact things that the customer has provided us with order cover to do. In this way, we eliminate much of the inevitable risks, particularly with manufacturing activities. In practical terms, this usually means not launching work orders ahead of programme just to keep people busy, making sure batch sizes are aligned to order quantities, and driving out anything that prevents us achieving this, such as quality losses, part shortages, long changeover times, any delays or processing time variation. The final step of Lean is really a bit of a cheat. It basically just reinforces the fact that the pursuit of perfection is an endless journey and that our hunger and ambition for more improvement should be relentless. Now looking at Six Sigma in a little more detail, Six Sigma is focused on reducing variation to improve the quality of our products and services. The entire topic of Six Sigma is based around statistical techniques and probability theory. This means that it can be a little heavy and intimidating on the maths front. However, I'll have a go at explaining the basic principles and theory without the need to get scared off by the maths. This is really quite important since Six Sigma does have a tremendous amount to offer, and it's usually the principles behind the maths rather than the calculations themselves that bring the main benefit, and that should be accessible to all of us. So the graph shape that you see here on the screen is what's called a normal distribution curve or a bell-shaped curve. You might well have covered these at school in the past, since they're one of those almost universal truths of science. For example, if you measured the height of all the adult women in your town and plotted the number of occurrences of each of those heights, so for example the number that are 5'4", the number that are 5'5", and so on, you would always see this kind of shape. Now the same is true within most manufacturing situations or most business processes. So for example, if we were cutting lengths of wood or dividing up dough to make bread, you would find a distribution around the average measurement that carries this form. Whatever the shape of this curve, whether it's narrow and tall or broad and low, the form of the shape is always the same, and that's called the normal distribution. The clue is in the name. So, trying to avoid the maths and the complexity, if we look at this normal distribution curve, you'll notice that I've put a couple of features there on the right hand side. You'll see a couple of green curves outside of the shape of the normal distribution. And that's because when you look at the normal distribution curve, you'll see that if we look from the centre towards the right, you'll see that the curve initially is curving downwards, but then it starts to curve outwards. This point at which the curve changes from turning one way to turning the other way is marked by the point on the graph, so the red point on the graph. And that point of inflection on the normal distribution is called the point of standard deviation. And that's all the sigma in the Six Sigma means. Sigma is the symbol to represent one standard deviation. So where that point of standard deviation starts to become important, and where the understanding of that standard deviation becomes important within Six Sigma, is viewing that in relationship to the tolerances or limits that we're trying to work within. So I've put a few different examples of a standard deviation curve on the screen on this slide, and you'll see that their only difference is the breadth of the curve. Now, all of those curves have exactly the same shape, and for all of those curves you can determine the point of standard deviation. But I've also added there some control limits, and they're represented by those red lines. In the top graph, what you'll see is the shape of the curve and the breadth of the curve is much wider than the control limits. So in that example, the process and the level of repeatability of the process is outside of the tolerances of the requirement. And in that case, any of those occurrences outside of the red lines would represent defects. They'd represent occurrences where we've failed to meet the specification required of the customer. In the middle graph, we see quite a different thing. What we have within the middle graph is an example of where the control limits, or where the tolerances, equate to 3 times that standard deviation point. So that point at which the shape of the curve changes is a third of the way from the centre to those control limits. And in that case, we're able to predict exactly, again, the number of defects that we'll experience. In the first example, around a third of all of the components made would be outside the tolerances. In the second, where we're working at plus or minus 3 standard deviations, there's only 0.2% defects. So 2.7 defects every 1,000 products. In the last graph, the one at the bottom, this is what's represented by Six Sigma. And this is the concept or the ambition with Six Sigma. We're trying to get to a situation where we are so comfortably within the control limits in terms of the variation of our process that it's almost impossible to produce a failure. Now, it doesn't matter what these control limits or the standard normal distribution curve here is measuring. It could be measuring our quality performance, it could be a measured variable in terms of a measured value, so a measurement of a component, or it could be delivery schedule achievement, where we've got a certain delivery window. The ambition within Six Sigma is get to the condition represented in that bottom graph, where the control limit is 6 standard deviations from the mean of our curve, in which case the probability of having defects is exceptionally low. We're down to a position here where we've got 3.4 defects per million delivered parts, which is significantly better than the previous examples. So now we've spent a bit of time exploring what each of those systems, Lean and Six Sigma, are, and the basic philosophies and focuses behind each one. Which one is actually the best? Well, returning to the hammer and screwdriver example used in the introduction, personally I have both tools within my toolbox. Why wouldn't you? The two methodologies actually complement each other extremely well. There's already a large degree of overlap when it comes to the individual tools and techniques within each, but each also then contains some additional, more specialist methodologies that can be used to achieve some very specific types of performance improvement needs. And in most business situations, you're going to have examples where both requirements come up from time to time. By way of example, the Lean methodology includes methodologies like changeover reduction techniques, and these focus on that elimination of the non-value adding time between jobs whilst we're doing the changeovers or the setups. We would do this typically so that we can reinvest that time saving to allow more changeovers and setups, so that we can have smaller batch sizes and achieve greater production flexibility. There are some extremely powerful methodologies within Six Sigma, particularly things like statistical process control. This can be used extremely effectively to manage and minimize process variation, or to look for the correlations between the inputs and the outputs of a process in order to prove cause and effects, take actions and eliminate waste and process variation. There's a system that has now become extremely popular called Lean Six Sigma, which is, as you might guess, a combination of the best of both of those schools of thought. And we will cover this in more details in some future videos. We may even put together a green belt level training course covering the entire scope of Lean Six Sigma. For now, I hope you found today's video interesting and useful, and I hope that you're now in a position where you've got a pretty reasonable understanding of the philosophy behind both Lean and Six Sigma, and would be able to explain the differences and the benefits of each to colleagues. So I hope to see you again soon, and I look forward to seeing you in the next video.
We do hope you found today's video interesting and informative. If you did, please click the like and subscribe buttons below. This really helps in getting our videos prioritized and found. Thank you and ciao, the Great Beard Academy.